Well, if you've followed this live long enough, you know I got my PhD in chemistry at the University of Michigan. And if you happen to follow college football, you might know the score of a particular game yesterday. They call it the greatest rivalry in all of college sports, maybe even all sport. That's right, Michigan versus Ohio State University. I watch it every year. And yesterday we were unbelievably victorious. So I just thought I'd start the live out with some colors. Hey, Dunko, come on, baby. I had to start the live today celebrating a big win yesterday. Too bad at the end of the game, though. It was marred a little bit. U of M players should not have, let's just say, engaged in some of the antics that they did, trying to plant the flag in the middle of the O. I thought that was pretty classless. Hello there, Kanika. We're going to get to the experiments here in a second. All right. Yeah, I thought that'd be a great way to start the live today. We're just going to hang out and do some science experiments. Here we go. All right, welcome aboard, folks. Let's do some chemistry experiments. Get her going. What are we going to do? Let's drop a little acid over here on the right-hand side. Over here on the left as well. Might see some color changes. And as you see those color changes, you can match those colors to what you see here. And by doing so, you can tell whether the mixture is acidic, such as this is over here, or basic. This one looks like it's maybe a little slightly acidic. It's not quite green, it's a little less than green. And if I continue to add acid to this one over here on the right, you'll see the color shift to a red color. And that just means the pH is dropping, which means you're going to a more acidic solution. And then we'll try adding some base to both. What do we get to? About pH 5 over there on the left. Here we go. Let's start adding some base over here. A couple drops. No, that's not base. I was like, why isn't it turning different colors? Because I was adding acid. Here we go. Let's add a bit of base over here on the left-hand side. You see that flash of blue? That flash of blue tells you that I've added some base. But, the blue color disappeared because there's enough acid in here to consume the base that I've been adding. Let's continue to add base over here. One drop. And yeah, again, the acid consumed the base, but you'll notice the pH went from 3 to 4. So, while the base was consumed, it increased the pH a little bit, making it a little more neutral, making the acid a little more neutral. I'll add another drop over here. We'll add them a drop at a time. We'll do it over here on the left as well. So in goes your drop of base over there on the left. And as long as your pH, thank you there, Mocha, as long as the pH is below 7, it's acidic. And right now it looks like both of the flasks are pH 6. So they're just barely acidic. I'm going to add one more drop of acid over here on the right. One more drop of acid over here on the, base on the right and one on the left. You can see now I've neutralized the acid on the right. Looks like you got a little ways to go over here on the left. Let's add just one more drop of base. See what happens. You get some beautiful flow patterns. How you doing there, Adiaman? Good to hear from you again. All right, let's add 2 drops of base to each. And you can certainly see that now the solution on the right is pH 10, which is quite basic. Hello, Jennifer. And the solution on the left is also now quite basic as well. We're just doing the, hello, Jennifer. We're just doing the experiment where I take universal indicator. It's also known as rainbow indicator. And I add that to some water in 2 flasks. Thank you there, Toon Boys. And then I just add acid or base, and you can watch what happens. And then we just, we talk. Okay, let's add a drop of acid over here on the right. Drop of acid over here on the left. You can see the red line going through there where the acid is. Hello there, Ariel. Yes, Jennifer, this is real acid. The acid I'm adding is hydrochloric acid. It's the same acid that's found in your stomach. It's just that the stuff that I'm adding is like 100 to 1,000 times more concentrated. So each drop of this that I add has 100 to 1,000 times more acid than one drop of the same fluid from your stomach. Toon Boys, it's similar to a litmus test. A litmus paper, however, only shows two colors, red in acid or blue in base. This shows a variety of colors at different pH values. Jennifer, I just saved these. So once I'm done, I have learned that I need to make the pH somewhat acidic. If the pH is somewhat acidic, I can just leave it here on the shelf and I can come back to it later. I'm going to add if I make it basic, then mold tends to grow in the solution, so I don't do that. The acid I'm adding, Captain, is hydrochloric acid. Make it yellow, says M. Here we go. Yeah, you can. I apologize, I can't pronounce your name. I'm going to call you Sigma. Yes, you can make universal indicator paper as well. Jennifer asks, hello, Sarah. What is the difference between an acid and a base? There's your yellow M. The difference between an acid and a base is an acid, the way we chemists, this is one way we think of it. This is the easiest way to describe it. An acid, here I'll add some drops of acid to both. 1, 2 drops over here, 1, 2 drops over here. When I add acid to these solutions, what I'm doing is I am increasing the concentration of protons. That's what acids do. They donate protons. Well, what's a proton, you might say? It's a hydrogen atom that's lost an electron, and we symbolize it like this. H+. So acids donate H+. Bases accept these. So any molecule that will donate a bunch of this to the solution, we're going to call an acid. And any compound that grabs onto these and binds to it, takes it out of solution, we call those bases. Thank you there, Sigma. Hello there, Truck Spotting. We got North Korea in the chat. Hydroxide for base, that's correct. Happy to see you, Sarah. Thank you, Captain, for the subscription. Here we go. Let's add some acid over here on the left. The right. And we're going to add drops of acid over here on the left as well. Check out what happens to the color. Look at that beautiful color changes that are occurring over here. It's interesting because you'll see at times a variety of colors in the solution. And what's going on there is you have different regions of pH in the solution. As the acid and the base react with one another, you will get different regions with different pH until the solution homogenizes. Try to make number 1 green and number 2 orange. Here we go. Number 1 green. Let's give it a shot. To get it to green, I'm at pH 5. I'm going to add base to increase the pH. So I'm going to add 1 drop and see what happens. Thank you there, Truck Spotting. I have kind of been into chemistry, I would say since the late 1980s. Idiamen, these are not buffer solutions because the pH is changing quite rapidly upon addition of acid or base. This is not acetic acid. So I think, what do you ask? Green on 1, and we want orange on 2. I think that was what we were going to ask. Yeah, I'm going to be in the live for at least an hour here, Sarah, is the plan. Yes, Captain, it is possible to reach negative pH for acids. It is totally possible to do that. If you happen to understand logarithms, the pH is actually the negative logarithm base 10 of this concentration. So if your concentration of protons is, say, 10, the unit we use is moles per liter, the logarithm of 10 is 1, and the negative of that is negative 1. So very highly concentrated acid solutions are going to have negative pH. I cannot make them colorless again. Thank you there, Musa. I appreciate that. Some glitter would look cool. We might do some glitter. But I think somebody asked for green on 1 and orange on 2. There you have it. Yeah, we might do some glitter experiments. We could do that later. All right, let's start adding base to both. Now you can see the acid I'm adding, orange, is hydrochloric acid. It's the same acid that's found in your stomach. I'm adding base to both right now. The base I'm adding is sodium hydroxide. I don't have any metals. Well, actually, I do. Actually, I do. I'm not going to make any of that swagness. How about red and purple? Asked Thorians on blades. You got it, IDM. And here we go. We want purple over here. I'm going to try to add a drop of base over here on the left to try to get this to be violet. There you go. And now over here on the right, I'll be adding hydrochloric acid, same acid that's found in your stomach. And that should make it red. Commando, go ahead and Google it. Gastric acid is synonymous with hydrochloric acid, except gastric acid is going to have, enzymes in it like pepsin. So, there's other material in there, but specifically the acid that the parietal cells in the stomach make is hydrochloric acid. What is the liquid in the glass, and what are the drops I am adding? The temperature of the acid is just room temperature. So, the liquid in the glass is water, and to the water, I have added some universal indicator. Universal indicator is a mixture of 4 different compounds, 4 different dyes, and those dyes change color depending upon pH, which is how acidic or basic something is. And together, they create these colors at different pH values. So you can keep your eye on this as I'm doing the experiments. You got it there, Commando. And what I am adding, like right now, I'm adding 20% by weight hydrochloric acid over here on the flask on the right. And over here on the left, I'm adding 20% by weight sodium hydroxide. Orange, the temperature of the water is also room temp, about 20 degrees Celsius. I can't explain how an ear works. I have no idea. I mean, I don't know how deep you want to get. I can, I understand how the eardrum and the anvil work. 10 QWERTY asks, can I drink this? I wouldn't drink this even when it's neutral, because one of the dyes in universal indicator used to be the main ingredient in X-Lax. It's called phenolphthalein. And that might end alive, I'd say, in, 10 or 15 minutes. I also don't know very well the toxicity of the other compounds involved. Why is the vortex so much smaller on the left? Asked Random Brain Cell. Let's check it out. I'm going to turn off the stir bar down here. All right. I want you to look at the size of the stir bar in this one. And then I'm going to turn off the stir bar over here on the left and look at the size of that one. So you can see the stir bar on the right is much larger than the stir bar on the left. And that's what gives them different sizes. I'll go ahead and turn them on, even if they're at the same speed. So I'm going to go ahead and turn them halfway on both. Do I have any 110 phenanthrene? There's SS. There's no, Sigma. Hello, Monique. There's no 110 phenanthrene in these unless you were answering someone else. So Bella Spaggi, I think I answered why it's not tunneling as much. There are different sized stir bars in each. The question from Sigma is, isn't neutral drinkable? Sure, there's a lot of different pH values that are drinkable. However, I wouldn't drink this because the phenolphthalein that's in there, it's a laxative. Rye, I cannot. I don't know anything about that. Rye Young lives. But if you want to, enlighten us, I do not know the answer to that. Not drinking it, Noah. No way. Not happening. Uh-oh. I think we got it. We might have it. Oh, it's not quite blue over there on the right. I'm hoping to get the blue. Come on, baby. Let's see if we can get blue on the... Oh, it's violet. Not quite. Hello there, Daisy. I can't make them white. Kamavinga, we are doing a chemical reaction right here. Isidore, the indicator solution is not the same as litmus. Litmus is either blue in a base or red in an acid. This shows a variety of colors in addition to red and blue. So from which pH does an acid / a base become dangerous as captain? I would say, first of all, I'm more concerned about the toxicity of a compound than I am about what acids or bases can do to me to a large extent. So there are some, for example, acidic compounds that are necessary for life that if dissolved in solution have a fairly low pH, like ascorbic acid. That's vitamin C. You need that to survive. There's a bunch of other acids that you need to survive as well. Generally speaking, though, I'm not going to mess with, I wear gloves with this stuff because the pH is quite low, and gloves with this because the pH is quite high. I'm going to say you get into, the range where you're below, like pH 1 or the base is about pH 12, then I'm a little worried about it. Put hot dog in it. Come on, man. Make them both crimson red. All right, you got it. We'll try to make them crimson red here. Here we go. I'm not making liquid lime. I'm making sodium chloride as I react the acid and base together. So here's the chemical reaction that's happening. Sodium hydroxide reacts with hydrochloric acid to form water and salt. Right now, it's red, so there's an excess of hydrochloric acid, and there's like no hydroxide in here. Now what I can do, however, now our pH is like a 3. As I start to add base to these flasks, it'll start to neutralize. Thomas, tell your baby brother happy birthday. Glad to hear it there, Black Hole. Sorry, Ryung. Thank you. I had heard of pyrogalol before, but I'm not an organic chemist, so I can't see the structure in my head. And I'm very clueless as to what pyrogalol is, but I'd have to look it up. Now deep blue is tough to get. Put Listerine in it. Hello there, Snowball. Deep blue is tough to get. Violet's easy, but deep blue is tough to get. We're going to give it a shot here. We're going to try to get to blue because, I think that's going to go to violet over there on the, come on, maybe I'm going to get it to blue. Let's see what happens. It is like a tornado. What's different about an acid neutral base, Ariel? What is different is the concentration of protons or hydroxide. So in an acid, you're going to have a lot of protons around, H plus ions. Those are hydrogen atoms that have lost an electron. We chemists call those protons. There's plenty of those around in an acid. In a base, there's a lot of hydroxide ions around. And in a neutral solution, those concentrations are equal. The concentrations of acid, H plus ions, and base, OH negative ions, are equal. Casting spells. Not casting spells, just doing a little science. Can I make it stay purple? Well, I got some purple over here for you, Denny. Here we go. I'm going to try to add just a little bit of acid here to drop this from a pH of 10 down to 9 to try to get it to blue. If you'll watch up here, what I try to do when I add a bit is I just add a drop. See that? I just added it to the side, and then as it sinks in, it's just a little bit of acid. We'll see if I can't get this to change to a blue color. Snowball, what I'm doing is I'm doing experiments with acid base and acid base indicator. As these solutions change color, you will see as I add acid or base, the solutions change color, and you can tell what the pH is and the acidity or basicity by just keeping track of this color scheme here. All right, somebody wants me to, they've been very patient. They wanted me to react a metal with some acid, so I'm going to do that. I've not done this on the live before, but we're going to give it a shot. We're gonna try this. So this is a penny that I've melted. This is a United States penny that I've melted. And you say, wait a minute, that's illegal. No, it's only illegal if I try to sell this, okay? So you can see here on the penny that this is coppery because the way they make pennies nowadays is they take copper and plate the penny with copper, but the inside of it is actually made of zinc. And if you see here, you might be able to see kind of a silvery metal that was melted out of the penny. Now, if I can do this just right, and this is a little hard to do because of the focus. I'm not sure this is going to work, but we're going to give it a shot anyway. Give me a second. Let me see if I can put this in something. Give me a second here. Do I have a cup I can pop this in? Y'all are pushing me to do stuff I've not done before. It makes it a little tough here. Okay. So I'm going to take this penny. I'm going to pop it in this cup. I'm going to take this off here, and we're going to try it a second. I don't know if this is going to work, but somebody's been very patiently asking me to try this, so we're going to try it, all right? I'll turn this off here. Yeah, it's not looking real good, but I'm doing the best I can here. All right, so you can see the penny. You can see over here on this side, that's the copper coat. Over here on this side, that's the zinc metal that I melted out. And what I'm going to try to do is I'm going to try to add some hydrochloric acid to the penny in this plastic cup. And hydrochloric acid reacts with zinc and it forms hydrogen gas. So forgive me, I'm trying to do this and film at the same time. And this is not the easiest thing in the world to do. But let me just go ahead and add a few drops here. Oh, yeah, look at that. You see those bubbles? Sure, that's the reaction I would expect to see. You'll notice it only happens with the zinc and not the copper. Those bubbles are hydrogen gas bubbles. So I'll write down the chemical equation for what's happening here in a second. But yeah, that's hydrogen gas that's being produced. Let's add another drop. Here we go. So again, you can see that the bubbles are forming on the zinc side. Look at the steam coming off. You see that a little bit? Oh gosh, a little bit of fumes. Woo! That doesn't smell real good. I wonder if that's because it's reacting with the cup. Come on, man, y'all are making me kill myself down here. Oh, gosh, that smells awful. Ha! Woohoo! Man. Anyway, you can see that the zinc is reacting and foaming, but the copper is not. And that's because zinc indeed reacts with hydrochloric acid, but copper does not. The bubbles are sigma sigma. The bubbles are hydrogen gas. A hydrogen black hole is it's odorless. Come on, Only Alias. The chemist has entered the chat. I want you to look at that comment. Only Alias has placed the comment in the chat that is the chemical reaction for what we are observing. So thank you there, Only Alias. I love it when there's some chemists in the chat. Appreciate that. All right. I had a little trouble reading comments while I was doing that and trying to do the, Anyway, thanks for being patient with me. Thank you for the suggestion for that reaction. Fortunately, I had a melted penny. That would be hard to do during a live, to melt the penny. I'm not sure I could pull that off. Although I suppose I could try it. Am I Heisenberg? I am not. Heisenberg in, Breaking Bad, he was what we call a synthetic chemist. And synthetic chemists, they make new compounds, or they know how to make various compounds. You can tell that from Breaking Bad. I'm not a synthetic chemist. I'm not real good. Thank you there, Daisy. I'm not real good at making stuff. What I am good at is understanding chemistry. I'm a physical chemist, and physical chemists, what we do, we're basically chemical physicists is what we are. So we study chemistry through the lens of physics. And that allows us to, understand chemistry fairly deeply. Thank you there, Black Hole. I love it. So Denny wants some orange. Come on, I'm going to give you a shot here. Let's see if we can pull it off. I won't be doing that, Toby. It's Kushal. I don't think I can produce enough hydrogen gas in the live the way it's set up currently to try that, but that's a great idea. Could you mix an acid and base? I'd like to see the color of that. Sure we will, Moss. This is a fun experiment. I'm glad you asked. So we're going to do this experiment for Moss. Let's see. All right, I'm going to add a bunch of acid over here on the right-hand side. So notice as I add the acid, the color shifts to red. The pH lowers, right? We went from an orange color to a reddish color. The pH drops as this gets more acidic. Now over here on the left, I'm going to add a bunch of base. Okay, here we go. Let's add a bunch of base. In goes a drop. In goes a drop. Look at that beautiful swirl pattern you get on that smaller stir bar. So now over here, I have a pH of 3, which is very acidic. Over here on the left, I have a pH of 10, which is very basic. And now what I will do is I will mix the two. Let me find my beaker for mixing. Forgive me a second, I gotta find it. Here it is. The question was, what happens if you mix the colors when they're acidic or basic? So what do you think is gonna happen? I'm gonna mix some of this and some of this in a beaker. Let's give it a shot, see what happens. You should be able to guess. You should be able to guess what's gonna happen if I do this. All right, keep your eye here, this will be mixing it. Thank you for the suggestion. All right, so up here at the top, you can see I'm gonna pull out some purple. I'm gonna pull out some of the red. We're gonna mix them together. We'll do it a couple times here. Probably make a little bit of a mess. I usually have to clean up a little bit when I'm done. Were you right at what color you thought you'd see? Fighter09 says green. Fighter09's been paying attention. That'd be my guess too. But it might be the case that the acid and base aren't the same concentration, in which case we might see something that's a little different than green, okay? Couple more. Forgive me for not reading the comments right now. I'm trying to pay attention to the experiment. That makes reading the comments a little difficult. Let's see what we got here, folks. Squirt them both in. Check it out. Does this stain the glass? It does not. It does not. Here we go. So if you've been following along this live, you understand why when I mixed this violet solution and this red solution, I got a green solution. Basically, acid and bases neutralize each other. So the acid over here at pH 3 and the base over here at pH 10, when you mix them together, they make roughly pH 7. It's a little lower than pH 7. I'd say this is slightly acidic, but that's probably because the acid concentration here is a little higher than this. Yeah, I agree, Akash. Yep. So it's neutral. You got it, Corp of Krieg. Is the left one spinning slower on purpose? The left one actually is spinning. Look, they're spinning at the same speed. I got them both at 1/2, right? Half speed. Oh, maybe that. Okay, let's turn it up just a bit. Now they're both like half speed. The difference is this one is a small stir bar and this one is a very large one, and that's why you're going to see a difference in, you know, in the sizes of the tornadoes. I love it too, Corp. Glad to hear that, PCAT. Glad to hear that. Garden. Here in the United States, we use the term alkaline and basic synonymously. So that's just something you'll have to get used to when you're hearing my live. I use the word base and alkali or basic and alkaline as synonymous. Thank you there, Sagalov. Jose wants some yellow. Let's see if we can get a little yellow for Jose. It says we study this here in 10th grade. That's about right over here in the United States. I'd say probably here. I remember learning this in like 11th grade. Toby, what happens if I put my hand in the base and the acid? Not a whole lot. Not a whole lot. What I'm wearing the gloves for is this stuff. I don't want to get this stuff on my hand. Adiaman, I wish that was the case, but it's not true. What's the original liquid in the glass before all the acids and bases were added? Asked Denny. The liquid in the glass was first water, and then I added universal indicator. So that's pretty much what's in the flask. Robert, I'm not that kind of chemist. I'm not that kind of chemist. How you doing there, Mahawarga? Sorry, I'm not saying the name correctly. Moss, I am adding 20% by weight hydrochloric acid, which is the same acid found in your stomach. It's just more concentrated. And I'm also adding 20% by weight sodium hydroxide. Questions are coming through quick, so forgive me. I'm not quite able to get them all there. Hello there, Megan. Thank you for being a member. I appreciate that very much. Glad to see you here along. Can we do green as Wits panned? We're going to try it. I think I got your green over there on the right. Vulcan, one of the dyes in here is phenolphthalein, but there's also 3 other dyes. Hello there, it's Frey. Hello, Sans. Peter Griffin, I get that a lot. How do I make deep blue? How difficult it is? All right, lots of questions for blue. Let's try it. So right now I'm at pH 7, so I'm going to try to add base to get us to a pH 8 or 9. Thank you there, Rinchin. I can't. Come on, Reset. Come on, man. The Reset just sent me $2. Seriously, I really appreciate it, but it is not necessary. But thank you very much. I appreciate that a lot. I really do. You know, it helps. It helps pay for materials. Okay, I overshot. I mean, we're at like pH 10 now. Doggone it! I spilled a little bit on my diagram there. We're gonna try to get blue. Blue's tough to get. Can I make antimatter from a banana? Come on, man. Oh, let's see if we get a little blue color going on. Thank you there, Maharorga. Yes, Saad, it is spinning by magnets. Why is a smaller stir bar in the basic mixture? I just like to use different stir bars. It makes, it makes it a little interesting. Variety, just a little variety. You can see some interesting effects with the small stir bar. Now, you might notice I just added a tiny drop of base here because what I'm trying to do, I'm trying to get this to blue, and it's really finicky to get the blue color. So I really have to add tiny amounts of either acid or base. Let's see if I just got that in there. See if that gets us the blue color. I can't make we couldn't see ultraviolet. It does look like color changing Kool-Aid. Face reveal comes at the end. So at the end, when I've had enough, I flip the camera around, I talk to people. So that'll come at the end. Hello there, it's Frey. Yes, Jose, adding vinegar would also work. Adding vinegar would definitely work. Can we get direct reaction? Adding acid and sodium hydroxide came with it. Why are we doing this? Sunglow Gaming. We're doing this just because I think it looks beautiful. And, to talk a little bit about science. That's why. There's a lot of interesting things that we kind of discover together. There we go. Come on, baby. Noen, I apologize. I missed your messages. Hello there, Zamena. There you go. This is for my fellow University of Michigan fans. So long, Adi Aman. That right there is for my fellow University of Michigan fans. I see that, Toby. Yeah, I'll try that. Recreational science, you got it, Jody. Well, Nasandi, I know there's a lot to remember in chemistry. How do you manage? It's my life. I mean, it's what I do for a living, and I thoroughly enjoy it. I'm sorry, I just got to leave it here just for a bit. I went to the University of Michigan to get my PhD in chemistry, and they won yesterday. They beat Ohio State. So let me humor me here a little bit. So I don't have any sodium metal. Snowball, I'll do green here in a second. Hail to the victors valiant. Hail to the conquering heroes. That's enough. You all don't want to hear any more of that. Okay. All right. Drop in the chat if you're one of my fellow University of Michigan alum or fans. Lemon, I don't know who you're asking about. I apologize. What's the difference between a practical chemist and the other ones? I apologize. I don't understand the question. Oh, there's your green color for folks that were asking. Is soap acidic, Denny? No, it's basic. That's all right, Nittany Lions. I'm okay with that. I went to Bloomsburg University in Pennsylvania. I wrestled for them, and we beat the Nittany Lions when I was in wrestling. Absolutely. I was there for 5 years. We beat them twice. We tied them once, and we lost to them twice. No, I can't, PJO. I'll try purple, Declan. Aviation. What I'm doing is in both of these flasks is some universal indicator added to water. And when you add acid or base to universal indicator, it changes color depending upon pH, which is how acidic or basic something is. Somebody asked for violet, and so I got you that over here. I'm not Heisenberg, Dylan. Crimson, you got it, Sod. Over here on the right, I'm adding acid to change from pH 6 to pH 3. The base Nguyen that I am adding is 20% by weight sodium hydroxide. So it's 20% sodium hydroxide and 80% water. Someone wants orange. Add something organic. Here, I'll add my gloved finger. There you go. Latex. Scarlet and violet. You got it right there. The acid Yashika, I apologize. I didn't catch the name. Oh, crap. What was the question? Man, they come through so fast. It's hard to remember. Sorry, man. Do I have ice? I do not. All right, let's add some acid over here on the left. A couple drops. Base is the one that tastes bitter, Nguyen. Hindenburg, I love it, aviation. Acids are sour. Make it green. I think I may have done it, Iman. I think there's your green. I'm loving it too, baseball bros. What's the acid and base, Rinkin? The acid I'm using is 20% by weight hydrochloric acid. The base I'm using is 20% by weight sodium hydroxide, with the other 80% coming from water. All right, let's make this one. Harsh wants the rainbow. We're going to try it. Here we go. Let's get this one over here very acidic. So I'm going to do that here. We're going to try to make the rainbow. All right. Now I'm going to turn this stir bar off over here. And now I'm going to add a bunch of base here. Thank you there, aviation. I appreciate that. Here we go. We're just going to add I don't know. Let's see what happens over there, okay? Random. I cannot do pink. I can't do pink. What's past 10 look like? Asked the commenter. Past 10, it's all violet. 10, 11, 12, 13, it's all violet. Vrapo wants blue. Oh, blue is the toughest color to get. Yashika, it's pretty hard to make sodium chloride precipitate out. You know that, right? It's very soluble. So the sodium chloride that I'm producing in these flasks is staying dissolved. I'm trying it, Bros Gaming. We're trying to go for blue. Here we go. We're going for blue. I mean, there's some flashes of blue over there. Look at this over here. Isn't that pretty? Let's add a little more base over here, huh? Try to get a little better rainbow effect going on over here on the outside. Let's see what that does. It is pretty over there. It's like psychedelic, man, isn't it? It's like a freaky rainbow, huh? Hey, I got the blue. I got it. Come on, man. Somebody said they were going to subscribe if I got the blue. You don't need to. It's fine. I just like doing experiments for people. Orange. I got the blue, Snowball. All right. They want orange now. 8's tough, too. 8 and 9 are tough, man. Okay. Somebody said I don't need to keep moving the camera. Okay. Fair enough. Thanks for the comment. Appreciate it. Okay. So, somebody wants orange. Here we go. Let's do this over here on the left. We're going for orange. Isn't that interesting? We got like a pH gradient here. So you can see we start at the bottom at pH 10. As you move up, you can see it's like pH 7. And then up here at the top, it's like pH 3. It's really kind of cool. Really kind of cool. All right, so we are at pH 7. Let's add a few more drops here. See if I can get it down to pH 5. I'm adding acid. So I'm at pH 7. I'm going to add a few drops of acid. The one on the right does look cool. Thank you there, Secret Weapon. A little bit of that circuit. I'm loving it. I see it. I see it. Spin the not mixed, says the Friendlies Hopper. I don't know. Y'all want me to spin this or not? Let me know. What's pH 2? Snowball. pH 3, 2, 1, 0, negative 1. All those are red. pH 10, 11, 12, 13, 14, and higher is all violet. Can I drink base to not get acid reflux? Well, I mean, that's what some people do. Like when I get acid reflux, I take a Tums, which is taking a base. Thank you there, Deshika. I appreciate that. All right, folks who want me to spin it. Here we go. So now, if there's more base present than acid, we're going to end up with a blue or violet color. If they're equal, we're going to end up with green. And if there's more acid present, we're going to end up with a yellow, orange, or red color. Let's see. Here we go. Oh, let's try her again. Look at that. That was kind of pretty. Seeing it's kind of like a puff of violet going up there. What's this question? Are you able to swap the colors by increasing the opposite? Meaning, can you add enough base to the acid to make the whole thing a base? Yeah. Yeah, so here we go. So here we go, over here on this side, over here on the left, we're going to make this very acidic. So over here on the left, I'm going to add a bunch of acid. All right, and the pH is going to drop. We're going to get the pH 3. All right, hello there, Daniel. I don't have any lithium aviation. Okay, now what I'm going to do up here at the top, I'm going to start adding base 1 drop at a time. So you can see me adding right up there. In goes the first one. There's your drop of base. Let's see what happens to the pH. Bros, we're going to try to make some teal, but it's a little tough to get to. I can't, Iman. I can't make it transparent. We're going to add another drop of base. So you can see it's not quite as red as it was before. Hello there, John. Hello there, Alex. So notice, hey, I had a couple drops of base. We went from pH 3 to pH 4. The commenter says, make the rainbow. You got it. We're going to do that here in a second. Another drop of base. Thank you there, Yabushiga. Sorry I said your name wrong. Man, I murdered it. Hello, Saigan. Hello, Cyan. So we now add a pH of 5. Let's add another drop of base. And while I'm adding drops slowly, I'm going to make this acidic over here so we can try to make the tornado or the rainbow tornado. All right, let's add another drop over here on the left. Hello, Kat. Hello, Ethan. Hello, Roggy Nord. Hello, Walter. Hello, Shrek. Hello, Amor. Thank you there, Snowball. Thank you there, Pink. Thank you there, Ethan. Hello, Ethan. I'm not sure what magenta is. I can do red and I can do violet. Let's add another drop of base over here. Another drop of acid over here. We're going to try to make that rainbow over here on the right. Thank you there, Ford. Hello, IDK. Hello, Sebastian. Hello, Niles. Hello, Pink. Numbers 1 and 2 Mega Shark are red. I don't have any marbles. Hello, Bentley. Hello, Jim Apple. Hello, Aloe. Hello, Amor. Hello, Paul. Oh, Paul asked a question. What did I even put in there? Hello, Kat, Chrissy, Rosa, Boss, Kitten, Amor, Jackson, Sebastian, Leon, Amor, Gavin, Noan. Another drop of base. A little more acid over here on the right. Okay, here we go. Sorry, I'm a little tough to stay up with those comments. Here I'm going to add a drop of base to this to see if we can get the rainbow effect. Are you ready? Here we go. 1, 2 drops. Let's see if we get it. I better add a little bit more. Kinda. Not as good as I'd like. We're going to try that again. Let's add a bunch of acid here. Get it back. I mean, we're getting flashes of it, but every once in a while we get all the colors of the rainbow simultaneously. I love it when that happens. Hello, Aloland. Number 1 and 2 are going to be, anything below 3 is going to be colored red. Rinkin, how do you do this with household materials? Let me tell you here in a second. I'm going to try to get the rainbow here. Let's go, like 4 drops. Let's see if we get it. Come on, baby. There's your rainbow. We had a flash of the rainbow, folks. It was very short-lived, but we got it. We got it. So, yes, you can do this with household materials. What you're going to need to do is you're going to need to get some red cabbage, purple cabbage, and you're going to boil that purple cabbage. And when you do that, you're going to get probably a blue, a violet, or a slightly reddish-violet colored solution. And then you can get different colors from the red cabbage. They'll look like this at the different pH values. If you add acid, you'll turn it, vinegar, you'll turn it a red color. If you add, probably your tap water is going to make it these colors. If you add baking soda, it's going to get like these colors here. And if you add ammonia, it'll get it to green. Hello, King Gordon. All right, let's add some acid here. A big squirt of acid. See if we can get the reverse rainbow starting with violet. Kinda, yeah, I think we got a flash of the rainbow over there. Aviation, yes, I can harvest lithium from batteries. I've done a short on that, so if you want to check out my shorts, you'll be able to see me do experiments where I get the lithium out of batteries. I'm not adding any of the red phosphorus. What's this? What happens is you add 1 drop of base to a very acidic one, with the speed of the spinner being dialed down a bit with each drop. Okay, let's try it. Let's try it. Here we go. Over here, I'm going to try to get this teal. Teal's tough, y'all. Teal is a really tough color to get. But I'm going to try. I'm also going to try to do that other experiment over here. I'm doing 2 things at once, so forgive me if I lose my brain here a second. There's your deep red turmeric. Oh, Pollock. Yes, that's correct. All right, let's add another drop of base over here so we can get that baby to teal. Snowball, we'll do that. We'll do that next. Thank you there, King Gordon. So long, Noan. Another drop of base. Okay, now we're going to try this over here. We're going to turn this down, and I'm going to add a drop of base with it. Add a rock. I don't have any. Hello there, Josie. Thank you there, Lexi. Hey, I got your teal. Come on, baby. I got your teal. Yeah, you can keep changing the colors there, Rinkin. It doesn't work indefinitely because the colors start to, it is organic material, and that organic material will start to oxidize and degrade. But it lasts, you can do it for a couple days. Yes, they're turning into salt for sure. All right. Aren't they making salt? That is correct. Pollock Roy, they are making salt. Jim Bro says make both the rainbow. Double rainbow, huh? You all are challenging me, huh? So long, Noan. Thank you, Josie. We got pH 8, Zach. We got it. That's a good idea, Aviation. I may try that. GE Maple. Can I do orange? Oh, boy. All right. Folks want a double rainbow. All right. Goodbye, teal. We're going to add a little bit of acid over here on the left. We're going to add a little acid over here on the right. We're going to try to do double rainbow. Never done that before. I doubt it's going to work. I'm not taking a sip. Sip, Marin. One of the dyes that's in here is a laxative, and that might end the live in 10 or 15 minutes. I'm not making any boom booms. Doing okay, Ghosty boy. Thank you there, cat person. I agree. I think chemistry is very cool. Rami, I'm loving some science about space too. The chemistry of space is cool. Eli, if I took a sip of this, the live would probably end in a little bit because one of the dyes is a laxative. Vulcan. That's right, Snowball. Acid and base makes neutral. Thank you there. I apologize. I can't say your name. It looks like it's in Russian. I have no idea how to say that. I'm very sorry, but thank you for the subscription. Okay, thank you there, Lexi. Thank you there, Lexi. Thank you there, cat person. All right, Jim Bros, here we go. Here we go. We're going for the double rainbow. All right, let's see if we can do this. I am Miss October. Here we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Let's see what happens. We got rainbow action on the right for sure. Come on, and I couldn't get it. Look at that rainbow on the right. We totally got it. But not on the left. I don't think we did. I do too, Eternal. The concentration of, that's nice, Pollock. Sir Rivet, that's funny. Okay, here we go. Here we go. We're going to try again. We're going to try to make double rainbow. I'm going to put a bunch of acid over here, bunch of acid over here. We're going to try that double rainbow one more time. Oh, Jimbo, you're fine with it? We're going to try it again, Jimbo. We're going to try it one more time. I like the idea. Let's give her a shot. Palacroy, what I am using is 20% by weight sodium hydroxide and 20% by weight hydrochloric acid. That's all I'm using. And then it's just water with universal indicator added. It's easy. I do not, cat person. Again, Palac, I'm using 20% by weight hydrochloric acid and 20% by weight sodium hydroxide. Thank you there, Draking. I appreciate that. What's my favorite food, asked Josie. Well, I mean, my favorite food I can't really eat anymore. I had a heart attack 3 years ago, so I don't eat, I don't eat what I used to. But, man, I miss having steak. I got to tell you that. All right, here we go. Here we go. We're going to go for the double rainbow here. Here we go. Salts are forming, Moss. They're just staying dissolved. Here we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's see if we get a rainbow going. I think we got it. Look at that. Come on, baby. Double rainbow. It doesn't last long. It lasts a little longer over here. Look, you can see that blue-violet line down the middle. Favorite color? Probably violet. Oh, we got it, man. We did it. Thank you there, Sladen. Thank you there, Mixley. Oh, we can try that. They want the... They want to try to get gradient on both. So we'll try that. I'm going to add a bunch of acid over here, a bunch of acid over here. We'll try to get the gradient. Thank you there, Lexi. Eli, you're saying add 40. I don't understand what you mean by that. I apologize. Thank you there, the ones. Make them both purple. Ask Ulysses. Make your favorite color. Where'd I go to college? I got my PhD at the University of Michigan. I got my undergrad in state school in Pennsylvania. Okay, here we go. We're going to try a pH gradient on both sides. So I'm going to go ahead and add drops of base here, see what happens. We're going to add drops of base here. You get some really beautiful patterns when you do this. Let's see what happens. Oh, a little bit more. Just one more drop. Let's see what happens. Pollock, yeah, I do some different experiments live. This is the one I mostly do. Make red and green for Christmas. We could try that for those that celebrate. I recognize all the ones. I hope you get there. I hope you get. Josie, I think violet's my favorite color. I got some violet going on. I see. Late night. I don't have any of those solutions made up. Yeah, we got a little here. I think it needs a little more base over here. There's not quite enough violet color, so I'm going to add a bit more base. You can see the base floating down. Thank you, Sladen. Appreciate that. Oh, pH table again. Thank you there. Again, I apologize. I can't say your name. But yeah, pH table, they want that up. Thank you for the comment. It does look cool, LOL. I don't know what that means, cat person. So I'm not going to repeat it because, it'd probably make me look stupid. Thank you there, late night. Can't get their secret channel. Thank you there, Snowball. Water is 7. That's correct, the ones, except any water that's exposed to the atmosphere, any water exposed to the atmosphere is going to have some carbon dioxide dissolved in it. And when carbon dioxide dissolves in water, the water becomes acidic. So it's water that has the carbon dioxide purged that will be neutral. Got that pH gradient going on over here. Rami, thank you. Okay, yeah. That makes sense. So there's some folks out there who celebrate Christmas. So we're going to try to get red and green for those that celebrate Christmas. Let's try that. There we go. There's your green. And over here on this side is going to be your red. 1st of December. Of course, December is the month of Christmas. I'm not sure that's going red yet. Better get a little more acid in there. There we go. So long, Snowball. There you go. We got your red and green Christmas for those that celebrate it. Moss, there are salts that are forming. It's just that the salts that are forming are dissolved. So it's just salt water. Could you make one 10, the other 3, and then add acid to the 10 while you add base to the 3? That sounds fun, Emily. I'll do that. I will do that, okay? We're going to do Emily's suggestion. I like it. So she wanted to get this side red, or one of the sides red, and the other side violets, which I'm going to do. I'm adding base to the flask on the right. Okay, so here we go. We've got red on the left side. We've got violet on the right side. Thank you, Anton. Why is the water divided into layers when it's not stirred? Here's why I think. I should create the effect again. Let me do this first, Anton, and then I'll try to answer your question. Okay, I'm going to now start adding drops of base to this side, and I'm going to start adding drops of acid to this side. And the ones, they do fill up a bit over time. Here we go. Thank you there, Sauce. Here we go. Drop of base, drop of acid. Drop of base on the left, drop of acid on the right. Drop of base on the left, drop of acid on the right. Drop of base on the left, drop of acid on the right. 2 drops. Thank you there, Lexi. Drop of base on the left, drop of acid on the right. Drop of base on the left, drop of acid on the right. We're getting close to the same pH. Hello there, Ray. Drop of base on the left, drop of acid on the right. Drop of base on the left, sodium hydroxide base. Drop of hydrochloric acid on the right. Actually, a little bit more like a squirt. And now they're kind of at the same pH. Okay, here we go. Drop of base on the left. Drop of acid on the right. Happy birthday, Lexi. Hello, Tactical. Thank you there, Aniket. Drop of base on the left. Drop of acid on the right. Drop of base on the left. Drop of acid on the right. And it looks like we've got the left side almost completely basic. Another drop of acid over here. We're going to try to catch it up. Another drop of acid over here. Another drop of acid. Thank you there, Alicia. Appreciate that. That looks like Clemson colors. The ones, I would not drink them. One of the dyes in there is a laxative. Sir drinks a lot. I don't think you're going to want to do that. All right. So Anton, thank you there, P4 Unks. So I'm going to go ahead and turn this one off. Plant Hub, the acids and bases I'm using are 20% by weight sodium hydroxide and 20% by weight hydrochloric acid. So this is for you, Anton. I'm going to add some 20% by weight sodium hydroxide to the flask on the right. We're going to let that set. Now, what I think is going on here is the base is quite dense. And so the base is going to sink. And of course, as it sinks, it's going to neutralize the acid. And as it continues to drop, it should end up here on the bottom. But as it moves through, it's going to neutralize some of the material. And then down here at the bottom, you'll have the base, and that'll displace the less basic material that should end up on the top. That's right, Mahit. I am using universal indicator. The commenter, I don't have any in my basement here, so we're not going to be doing that. I'm getting to the point where I'm running out of steam here, folks. I've almost been doing this an hour. So I am going to, at some point, wrap up the live. And usually what I do when I wrap up the live is I flip the camera around. You can look at my ugly mug sitting here in my basement doing science experiments for y'all. I'm just giving you a fair warning that that's gonna be coming within the next 5 minutes easy, maybe even less than that. Universal indicator, cyanak. It is a mixture of 4 different dyes that change color depending upon pH. And those 4 different dyes are methyl red, bromothymol blue, thymol blue, and phenolphthalein. Happy birthday, Honey. Happy birthday. Nikur, happy birthday. This won't explode. Thank you, Ray. I agree, Nunya. I agree, Sauce. I love it, Moss. You got it, Anton. It didn't work as well this time, but you can still see the effect is what I think's going on. Happy birthday, Rich. You got it, the ones. Let's add some potassium hydroxide. I mean, okay, this is sodium hydroxide, but it's going to be the same effect, right? The potassium and the sodium has nothing to do with it. It's all hydroxide. Sanskar, I am adding 20% by weight hydrochloric acid or 20% by weight sodium hydroxide. SM, I do not dispose of the fluid. I don't need to. All I need to do, here, I'll show you what I do. I make sure that the solution is acidic because I notice that mold does not grow in these solutions if they are acidic. So I get the pH at about 3. And then I just save the solutions for the next time I do the live. Thank you there, Sharky Boy. Crazy Bean, I hope your exams go well. We got some nice effects going over there on the left, man. That was cool. Yes, Lexi, I am. I am indeed a teacher. Josie, I usually do my lives either Friday, Saturday, or Sunday. It's Sunday here where I live, Sunday afternoon. It'll either be, it's the afternoons on Sunday or Saturday, and if it's Friday, I do that on the evening. Every once in a while, I'll do some like earlier in the week as well. I'm okay, Mossy Kerr. Happy birthday, Parrish. All right, I'm going to flip the screen. I can hear my wife's home. I want to talk to her. So we're going to flip this around, talk to you for a bit. Whoop. Turn these off. Got my readers on so I can see everything that's going on. Sorry to hear that, Stewie. Cat person, I don't know, man. I wouldn't want to eat it. That's an alpha emitter. You don't want alpha emitters inside your body. Why am I doing this? Because I enjoy it. Anacat, that'd be nice. Hello there, SM. Go Wolverines, RL. Come on, baby. How do you make a buffer solution? So to make a buffer, what you do is you add roughly equals amounts of an acid and its conjugate base. And the acid will react with any added hydroxide, and the base will react with any added protons. Thank you, Shendrickson. I appreciate it. I like math too, Jose. It's 1 a.m., Sophia. Oh, my goodness. Thank you there, Draking. I appreciate that. I love it, Nada. Thank you there, Polziet21. Shane, come on, man. Sanskar, I would like to do that. I have a couple of those planned. It's just, as you can tell, that's a little different. Sure, Lexi. I think I need to do an experiment with aquaresia, for sure. I do too, Sophia. Thank you there, Hallucination. Thanks for hanging out, Josie. It's Monday, huh? Happy Monday. I do, Sophia. I'm a physical chemist, which means I think about chemistry from the perspective of a physicist. Thank you there, Shendrickson. Thank you there, SM. Stewie, I won't be doing that. Come on, man. Me too there, drone. Sui drone. Loving some. I hope you're doing well in physical chemistry. Thank you there, Nahal. I appreciate it. Thank you there, Lexi. I appreciate that. Thank you, Mahit. I wish I had you in my class. Love teaching some general chemistry. Thank you there, Yunsky. The ones, you check out I'm not going to do an explosion on a live. I just don't think that'd be wise. I don't think YouTube would go for it. However, there are some experiments I've done, on my shorts that you can see some things that, do that. Thank you there, Mahit. Great. I love my my subscribers from India. You all are all great. Did you see the video I made for you all? I did a video for my people who watch my channel from India. Patrick, I don't think so. Well, okay. Depends how you're asking the question. Thank you there, Shendrickson. Thank you, Sophia. I appreciate that. Patrick, I have no idea. What an interesting question. What would that even look like, right? What would it look like if time was expandable? Someone's in Netherlands. Interesting. Good night, Stewie. That's funny, Victor. Hello, garbage. All right. I'm gonna hang it up for the night. Appreciate y'all being here, looking at some of the beauty of some goofy science experiments. But just pay attention to the world around you, right? I mean, the beauty of this universe is everywhere. You know, just pay attention. Look at the clouds, listen to the bubbling of the brook, check out the birds, the way they fly, the blueness of the sky, sunsets, sunrises. Man, it's all there. So, yeah, take some time and check it out, and we're going to see you next time. Love you guys. Thanks for being here, and we'll see you next weekend.